And welcome back. Mr. Wakefield here, looking at 9.3. And we're going to continue to expand on what we learned with radicals in the last section. We were learning about how to simplify them. We're definitely going to need to know how to do that here. Right now, what we're going to learn how to do is to add and subtract radical terms. Okay, and it's actually very similar to what we did at the very beginning of the semester, where we learn how to add and subtract regular monomial terms. Okay, and we learned that you can't do that unless the variable part of the term is the same. In other words, they have to be like terms. You can't add and subtract terms unless they are like terms. This is from the very first worksheet of the class this semester right here. Since the x squared and x squared were the same, I was allowed to combine the 7 and the 3 into one term here. Whereas here, the reason why I don't try to add these together is because the y5 and the y3 are not the same. Okay. Well, the way it works here, first of all, I need to define something first, and then I'll tell you how it works here, but it's very similar. But we got this thing called a radical term. It's not the same thing as a monomial term, okay? But what it is it is either a regular monomial term being multiplied by a radical, such as, say, for example, this right here. See how you got a regular term 2 that doesn't have a radical in it, being multiplied by a radical. Okay, and the key thing there, just like with regular terms, is the times right here. Okay, if you have 2 times the radical, it's still one term right there. Just like when you have 2 times x squared, that's still one term because of the times. Whereas if it had said 2 plus x squared, that would have been 2 separate terms, because a plus sign, just like a minus sign, breaks it up into different terms. Okay, but the multiplication keeps it as one term. So if you have just a regular term like 2 being multiplied by a radical, that's all one radical term, even though it has multiple parts to it there. Okay, so this is a term also, a regular term 3 being multiplied by a radical. This is also a term here, okay, because it's a regular term being multiplied by a radical, okay? And so you got these 3 radical terms here, then it says that they need to be added and subtracted. Well, the problem is that we have this thing called like radical terms, all right? Not to be confused with like terms from before, but it's very similar, like I said, in that just like before, you needed the variable part of the term to be the same in order to add and subtract. When you have radical terms being added and subtracted here, with the plus and the minus in between them here, the radicals need to be the same. The outside of the radical doesn't need to be the same. Just like the coefficients, okay? Remember, the coefficients 7 and 3, they didn't have to be the same there. Just the variable part of the term. Well, just like the variable part of the term needs to be the same, the radicals need to be the same. Okay, so the problem here is that they're not the same. But the thing that's different about these problems compared to the first day of class is that when you had the regular terms and they weren't like terms, you just gave up. You couldn't combine them. Okay, if they were if they had a plus or minus in between them, okay, you couldn't combine them. Okay, but a lot of times, though, when the radical terms are not the same radical and you need to either add or subtract them, okay, that does not mean that you give up. You can, because of what we learned in the last section, a lot of times when you try to simplify the radicals do then become the same here. Now, I wrote that down here, and this is not my best job of showing work here. I mean, if you look at it carefully, I think you can see what's going on. But in the actual problems that I do down here, I'll do a better job of kind of organizing it so that you can see it better. Okay. And then after you look at the problems that we do down here, I think this will make better sense to you. But this is not the best thing to look at for the first problem here because of how it's written. But don't worry, we'll go through it carefully, all right? Now, before we get into how do we make the radicals the same so that we can add and subtract the radical terms together, what we need to do is we need to talk about how would you combine them together if they were the same, okay? So before we learn how to make them the same, let's talk about what would happen if they were. Okay, these first 2 problems here, you can see that in this first one, you have two radical terms being subtracted, and they do have the same radical. The second problem here, you have three radical terms here with pluses or minuses in between them, and they all have the same radical as well. Okay, let's go back to the first problem though for just a moment. As I just mentioned, okay, when you have two radical terms with the same radical, it's similar to when you have two regular terms with the variable part of the term being the same here. Okay, just like the x squareds are the same here, the square root of 3 is the same here. All right, and so let me zoom in there. What I'm trying to tell you here, though, is that if the radicals are the same and you're either adding or subtracting, it's just like when you have like terms and you're adding or subtracting. Okay, what did we do to combine these together? We simply subtracted the 6 and the 4, right? And then the variable part of the term stayed the same. Well, the way you add and subtract radical terms is almost identical to that. You take the outside parts of the radicals, and they're just like the coefficients. So the outside parts of the radicals are just like the coefficients here, down here in this problem, where you add or subtract them. In this case, you subtract because it's a subtraction problem. And then just like the x squared is the same, and then it stays the same. And likewise, the radicals are the same, and then they stay the same. Okay, so you see there's a very close relationship between what we're doing in this section and what we did on the very first day of class. And so that's why this answer right here is 2 square root of 3. Okay, let's look at problem B here. It's very similar. Again, this is no different than if you wanted to write down, say, 4y to the third plus 2y to the third. It's not the same problem. I'm just saying it's similar to it. Okay. When you have three radical terms that are being added and subtracted, and they all have the same radical, it's no different than when you have three like terms that are being added and subtracted. And you do it exactly the same way, where the outside parts get added and subtracted, just like they would up here. What is 4 plus 2 minus 8? 4 plus 2 is 6, minus 8 is negative 2. And then the variable part of the term stays the same. Okay, same idea here. The outside parts of the radicals get added and subtracted, just like the coefficients do. Negative 2 again. And then the radicals, because they're like radical terms, you can in fact, you need to keep the radical the same. But you cannot add and subtract terms. Like I said a few minutes ago, you cannot add and subtract radical terms together unless the radicals are the same. Okay, and that brings us to problem C here. Notice how a couple of the terms here are the same, aren't they? Meaning they have the same radical. They're like radical terms. But then you have a couple of other terms that are the same also, but they're not the same as the first two. Okay, let me show you a comparison from the first day of class on that one as well. I'm sorry, that fell off the screen. Let me say it again. We have two terms that are like radical terms. We have two other terms that are like radical terms. They're just not the same as the first and the third one, that's all. Okay, so this is similar to like if you had, for example, let's say you had 6x plus 10y plus 8x minus y. You see how the first and the third are like terms right there? Okay, but the second and the fourth one are like terms also. Okay, it's just that they're not the same as the first and the third one. Okay, we were able to do that back in the first day of class. What was this equal to? Well, we were supposed to combine the first and the third, and then combine the second and the fourth. All right, we do it. We're going to do this problem the same way, but let's do this problem up here first. 6x and 8x is equal to 14x. 10y and minus y is 9y. And remember, when you're combining like terms, you got to either put a plus or minus in between the answers. Since that's positive 9y, I've got to put a plus there. Okay, so that's what you do with like terms, okay? If some are like terms and then some other ones are like terms, but they're not all like terms. It's just that you can pair them up, okay? Radical terms, like radical terms, work the same way, all right? You combine the ones that you can when you have a bunch of radical terms that are being added and subtracted. You just combine the ones that you can, okay, and make sure that there's either a plus or minus in between the answers that you get if you get more than one term in the answer, because they weren't all like terms, okay? So just like 6x plus 8y, we do 6 plus 8 here is 14, and since we combine the radical 3m terms right there, the radical 3m stays the same, like that. Just like the 14x, I now have 14 rad 3m. And then I combine the 10 and the minus right here. These are the second and the fourth one. And so 10 minus 1, just like I did 10 minus 1 up here, equal to 9. 10 minus 1 is going to be 9. And we got to put a plus or minus in between it. Since it's positive, I put a plus. And then the radical term, or the radical part of the term, rather, stays the same. Like that. And so that's how you combine like radical terms together. Okay? But as you see here in the next three problems, though, in each one of these three problems, along with the four problems underneath that down here, okay, the radicals are not the same. But in many cases, if you simplify the radicals in these problems where they ask you to add or subtract the radical terms, if you simplify the radicals first, they will become the same. Oftentimes. I'm not saying all the time, but oftentimes. Okay, and if they don't, then you can do something similar to what we did here. You combine whatever you can. But you don't combine two things that are being added and subtracted here if the radical terms don't have the same radical. So that's why I left this answer the way it is, because the two radicals are not the same. They're close to being the same, but they're not exactly the same. Okay, so here's what you do. Down here at the bottom, so that I have enough room to do my final couple steps, down here at the bottom, I'm going to simplify the 12 and the 75. The reason why I didn't bring down the 3 is because 3 is one of those radicals that is already simplified. Okay, remember, what do we do when we simplify? Well, if it's a square root, we try to factor out the largest number on the perfect square list, okay, or the largest variable exponent if there's variables, and that's how you simplify it. Well, with 3, the only thing I could factor out is 1, and we know that 1 is not going to make it any more simple, so it's already simplified. So that's why I didn't try to do this one. But I need to do the 12 and the 75. Don't worry about the negative 4 and the plus 2 yet. I'll get to that in just a minute. Just bring the radical down here. So I can factor out a 4 out of that, right? In fact, that's the biggest thing that I can factor out from the list. Okay? So I split that apart. Yes, you can jump right to, like I talked about at the end of 9.2, you can jump right to splitting those apart now to save you a step. And then you figure out what the first radical is equal to, keep the second one the same, and there you go. Okay? So we simplified the 12. I'll show you how to use that in a minute. Okay? Let's simplify the 75 first. What's the largest number on this list that I can factor out of 75? Well, it's going to end up being 25, all right, because 25 times 3 is 75, and none of the other numbers bigger than 25 are going to be factors of 75, all right? So if I pull that out, 25 and 3, okay, I get, remember, figure out what the first radical is equal to, keep the second one the same, and you get that right there. Notice what's going on here, though, you guys, okay? Everything's becoming rad 3, isn't it? Radical 3, radical 3, radical 3, all right? So it oftentimes ends up being the same radical. But let's see how we put all this together, though. So this radical didn't change at all. So just bring that down. But if you have a radical that changed when you simplify it, what you do is you still keep the outside part there, bring down the minus 4. But since it said minus 4 times rad 12, you're going to change that to minus 4 times whatever the rad 12 became. It became 2 rad 3, didn't it? So I changed the radical 12 to 2 rad 3, okay? Keep everything else the same, though. So the plus 2 stays the same, and then change the radical that you simplified to what it equals now. The rad 75 became 5 rad 3, and so I just bring the 5 rad 3 up here, since the rad 75 changed to that down here. Okay? 2 more steps to go here. Now what we need to do, notice that up here when we were combining like radical terms, okay, you just had one single term in front of each radical. Whereas down here, I've got like a couple of things in front of this radical right here. I've got minus 4 times 2. So what you need to do on this step is you need to multiply those parts together, okay? Let me remind you back in the last section, when you have something that's already outside the radical, and then you simplify that radical right there so that now there's 2 outside parts. How do we do that? We multiply the 2 outside parts together. The old outside part that was originally there, minus 5, times the new outside part, 4, but we keep the radical the same there. It's the same thing here. When you change the radical to a new answer there, 2 rad 3, or for 75 it's 5 rad 3, multiply the old part that was outside the old radical at the beginning times the new part that came in, the 2, and you get what here? There's nothing like that here because the radical didn't simplify, so you don't have to do that, that part there on this step. Okay. But negative 4 times 2 is negative 8, and then the rad 3 stays the same, just like it did right here, minus 5 times 4, and then you keep the radical part the same. Same thing here with the rad 3, it stays the same. And then you have plus 2 times 5 is plus 10. If there's a plus there, make sure to keep that plus, okay? Make sure to keep that plus. All right. And now we're ready to combine these 3 terms together, because just like these first two problems up here, they all have the same radical, and the radical terms, there's 3 radical terms here, isn't there? Okay. 3 of them. Remember, the radical term includes the term the regular term in front of the radical there. So these 3 things I circled are the radical terms, and they're all being added and subtracted, right? Subtraction, addition here. And the most important thing is that if you are subtracting and adding, and you have the same radical on all 3 of them, you can combine all of these together just like we did here. So how do we do that? Well, remember, you guys, and we've seen this before from the first day of class, and just anytime you combine like terms, okay, what if I had something like this? What if I had like x squared minus 8? This is a different problem. You don't have to write this down. Just watch this. But if I had this problem right here, you guys, x squared minus 8x squared plus 10x squared. Again, sorry, that fell off the screen there. If I had this right here, how would you combine that together? Isn't there an invisible 1 right there? So wouldn't it be 1 minus 8 equal to negative 7? And then negative 7 plus 10 would be 3, and then the x squared stays the same, right? I'm bringing that up right now because just like the x squareds are all the same here, the rad 3s are all the same here, but there's an invisible 1 in front of this one. When there's nothing there in front of it, that means there's an invisible 1 there, just like there's an invisible 1 in front of this x squared. So you got to remember to do 1 minus 8. Don't just say that this is nothing here. This is 1 minus 8 equal to negative 7. And then negative 7 plus 10 is 3. Just like I got the 3 up here, I got the 3 here. And then don't forget that when you combine the like radical terms, the radical part stays the same, and bring that down into the answer. Just like we brought x squared into the answer right here. Okay. Let's try that again now. So the radicals are not the same. I need to try to make them the same so that I can then subtract these two things. Okay? That's what we do when they ask us to add and subtract radical terms. We try to make the radicals the same if they are not the same already. Okay, let's start out with this one. Radical for 2. 2, you cannot factor anything out of that, right? 1 would be the only thing, and that doesn't count. So we skip that, all right? We saw that at the end of the last section here, okay, where sometimes you just can't factor something out here. Like with the 13, okay, nothing factors out of that, okay, so don't try to factor anything out. It's the same thing with the 2. So then we go to the x squared part. Well, the x squared part, what's the largest exponent that's not bigger than x squared? Well, it would be x squared, right? So we factor that out. And what's left here? Okay, well, x squared, since it's the same exponent as this right here, all right, don't put another x over here, all right? But x squared times what is equal to 2x squared? Remember, it's still got to be equal to this when you multiply. Wouldn't it just be equal to 2, right? X squared times 2 is 2x squared. All right, so that's where the 2 ended up. Since we couldn't factor anything out of 2, the whole thing just goes over here because it still has to equal 2x squared when you multiply it. Okay. Now, we then do the normal thing here. We figure out what the first radical is equal to. Okay. We know that x squared, the square root of x squared is just x to the first. Okay, because what goes in here? What goes in here? X to the first goes in there, right? Because 1 times 2 is 2. All right, so that must mean that x is equal to the square root of x squared. All right. Okay, and then the second radical stays the same, so there is your simplified radical term there. All right. How about 50? Similar to 75 in the last problem, 25 is the largest thing I can factor out of that. And you can see that once again, the radicals are becoming the same here in the end, aren't they? Okay. 25 and 2. We then figure out what the first radical is equal to like always. Second one stays the same. And now what do? We take our 2 radicals that we simplified just now and we change these radicals into their new simplified equivalents here. Since there was nothing in front of this radical here, you just take what it's equal to and just bring it up here to replace this, okay? So x rad 2 just replaces this. There's nothing in front of it, so you don't need to put anything in front of it as you come down to the next line here. Now you bring down the minus 7x because that is part of the original problem. You got to bring that down. We're just changing the radicals. Anything that's outside the radicals needs to come down in here into this next line right here that we're writing right now. And so this becomes what? This becomes 5 radical 2. Okay, rad 50 becomes 5 radical 2. And then just like in the last problem, okay, if you have a term that's being multiplied by the radical on the outside in the original problem, and then that radical changes so that it becomes a new outside part here, 5 times a new radical. It has the 2 parts now, the outside part and the inside part. You need to multiply just like we do with the minus 4 and the 2 and the 2 and the 5. You got to multiply the old outside part, negative 7x, times the new outside part, 5. That doesn't happen on the first part here. There's just one outside part here, so there's nothing to multiply. Remember, do not ever multiply the outside of a radical times the inside. Okay, but we do need to multiply the negative 7x and the 5. Okay. So that would give me minus 35x, wouldn't it? Okay, now we're ready. Now we're ready to combine these terms together because we now know what one term is in front of each radical. We had to do that multiplication right there to figure out what one term is in front of the second radical, but now we have just a single term in front of each radical. We can now combine those single terms. What is x minus 35x? In other words, what is 1x minus 35x? Wouldn't that be negative 34x if you combine those terms together? Okay, and since we are subtracting, it's just like combining like terms when you're doing the outside part. When you're combining the outside parts, it's just like combining like terms from the first day of class. 1x minus 35x minus 34x. And then the radical part stays the same. It is the same, and it stays the same. Like that. Okay, let's do one more here. This time it's cube roots. The process is completely the same, just like I said in the last section. When you go from square roots to cube roots, the process is exactly the same, except for you just got to look at the cube root list, or the perfect cube list. The perfect cube list. Different set of numbers you're looking at. Okay. And actually, this thing's already simplified, but I want to go through that carefully so you just to make sure you know why that's already simplified. So that's why I brought it down. Theoretically, you don't really have to bring it down since it's already, you can't simplify it. So 81. What can I factor out of that from the list here? The perfect cube list. Okay, I can factor out 27. In fact, that's the biggest thing that I can factor out. 64 is not going to work, and then everything else is too big. So 27. Now, you also got to do the variable part. Okay, the variable part says what? It says a to the fifth, and what's the largest exponent that's not bigger than 5? It would be a to the third, wouldn't it? A to the sixth would be too big. So I'm going to factor out a to the third. Okay. There we go. That is a 3 right there. Okay, I'm sorry that... make that a little bit more clear for you there. There we go. 27, a to the third. And so then what does 27 a to the third get multiplied by to equal 81 a to the fifth? 27 times 3 is 81. A3 and A2 are equal to A5. 3 plus 2 is 5. And so we then figure out what the first radical is equal to. What do you got to cube to get 27a to the third? You got to cube 3a. Okay. In other words, this one right here. What goes in there to equal 27a to the third? It would be 3a. And that's why 3a is equal to that radical. So we have 3a times the cube root of 3a squared. Okay. Speaking of 3a squared, though, that's already simplified. Why do I know that? It's because the coefficient, the only thing that works for the coefficient is 1, and then the exponent for the variable is too small for even the smallest exponent that we have, up here, which is 3. So again, if the coefficient only works with 1 and not any of the other numbers, and if the variables have exponents that are too small for even the smallest exponent on the list, then you know that that radical is already completely simplified. You can't make it any smaller. You can't break it down at all. Okay? But, and I'll go ahead and write that down here, but theoretically you don't even need to say this here. If you already know it, just keep moving with the problem here. Go on to the next step. Okay. So anyway, speaking of going on to the next step, let's go ahead and do that. So we take as we did in the last couple problems, we take the radical that we did simplify, and we replace it with its new equivalent that we found down here. And then the radical that we didn't simplify, just leave it alone. Just like with the square root of 3 on the problem D that we just did a few minutes ago. Same thing. All right. You didn't simplify it, so keep it the same. Then, just like we always do after you simplify a radical, if that radical already had an outside part to it, then that means that you're now going to have 2 outside parts, aren't you? And so they need to be multiplied together. 7 times 3a is equal to 21a. The radical stays the same as we talked about. Okay, and so now the radicals are the same now, but we also have a single term in front of each radical, so we know exactly what to combine. We have to combine 21a and 4a. 21a and 4a. What do we get? 25a. 21a plus 4a is equal to 25a. And you know that when we add and subtract radical terms, first of all, the radicals need to be the same. But if they are, then they stay the same. Like that. And that's your final answer. So we are adding and subtracting radical terms together, but we're only able to do it if the radicals are the same. And so don't even think about trying to combine anything together up here at the beginning of the problem, because the radicals aren't the same. It's different when you multiply and divide radical terms. We'll see that in the next section that we do. Okay. And that's just like regular terms as well. When you're multiplying regular terms, you don't need them to be the same. You don't need them to be like terms. Okay. But when you're adding and subtracting, whether it's regular terms from the first day of class or radical terms, okay, you need something to be the same. Okay. In the case of radical terms, it's the radical that needs to be the same. So adding and subtracting, something needs to be the same. Okay. We've also done fractions in this class now, and we know that when you add and subtract fractions, doesn't the denominator need to be the same? Whereas when you multiply and divide fractions, they don't. So there's this close connection here between adding and subtracting, the fact that something needs to be the same when you add and subtract, whether it's the denominator or the radical or the variable part of the term if you're just doing regular terms. Whereas when you're multiplying and dividing, and it doesn't matter if it's, again, fractions, radicals, or regular terms, nothing needs to be the same in that case. So, again, multiplying and dividing, nothing needs to be the same. Adding and subtracting, something needs to be the same. So it is always nice to have connections like that. It makes it easy to remember things. So I just wanted to share that with you. But let's go ahead right now and jump down to those last 4 problems. I'm going to have you try those right now. Hit the play button after that. And we'll take a look at those 4 answers and wrap up section 9.3. All right, let's take a look at number 1 here. The square root of 3 is already simplified, but the 27 and the 12, if you simplify those down here at the bottom of the problem, you see that they end up with that same radical 3 as well in those. So simplify those first, just like we've been doing. Then you what? Then you bring that down. Okay. You bring that down, or you bring it up essentially, but you bring it into the next step of the problem though. The 27 becomes 3 rad 3. The radical 12 becomes 2 rad 3. Multiply the 2 outside parts together on this step like we've been doing on the previous problems. Okay, the old outside part and the new outside part, which gives you what? It gives you 6 rad 3 and minus 6 rad 3. Again, this one didn't simplify, so you don't need to do that multiplication step there because there's already only one term there on the outside. Whereas on these, you had 2 outside parts, and so that's why we had to multiply them together to get 6 and minus 6. Now that I have a single term on the outside of each radical term, single regular term on the outside of each radical term, the 4, the plus 6, and the minus 6, I can now combine these together due to the fact that the radicals are the same. Okay, what do we get? 4 plus 6 is 10. 10 minus 6 is 4. And again, the radical part stays the same. And that's number 1. Okay, number 2. Again, the 5 does not simplify. That's already simplified. You can't factor anything out of that from the perfect square list. But I can do 20 and 80, though. 20 and 80. All right. And I get 2 radical 5 for 20, 4 radical 5 for the 80. And so what do I do there? I go back and I plug those in. The 20 becomes 2 rad 5. The 80 becomes 4 rad 5. Multiply the old outside part by the new outside part on the next step. Don't need to do that here because there are no outside parts here. And we get minus 4 and plus 12. Okay. And why do I end up with 9 as an answer? Okay, a lot of students will end up with 8 as an answer, 8 rad 5 instead of 9 rad 5. Why is it the 9 instead of the 8 in the front? It's because there's an invisible 1 in front of that first radical. Don't forget about that. So 1 minus 4 is negative 3, and then negative 3 plus 12 is positive 9. Radical stays the same, so we end up with 9 radical 5. Okay? Number 3. Number 3 down here. Okay. Again, we have to what? We have to simplify the radicals that we have. The 2 is already simplified. You can't simplify that at all. But the 8x squared and the 8 can be simplified. And so let's go ahead and look at that there. The 4 comes out of the 8. The x squared comes out of the x squared from the list. The perfect square list that we have. And so we end up with this right here. For the 8, just the 4 comes out. There's no variable on this one. And so you can see that both of these radicals become radical terms with the same radical in it. Not a surprise, right? That's what's been going on in these problems. Go back and plug in those new radical terms that replace the radicals we simplified. All right, multiply the outside parts together, the old outside part and the new outside part for each term. Okay. And that gives me 8x and minus 2x over here. So now I know what term is in front of each radical. Okay. 8x minus 3x and minus 2x. If you actually subtract those, you get 5x minus 2x is 3x, with the radical again staying the same. Okay. And finally, in number 4 here, be careful because this is a cube root problem. Just make sure you're looking at the other list now, the perfect cube list instead of the perfect square list. So looking at the perfect cube list, we can factor out 8. We can factor out 8 out of 8, okay? But you can't factor anything out of x squared. Why is that? It's because the smallest exponent that works for perfect cubes is x3. So x2 is too small to factor anything out of it. And so don't put anything over here for x. But since 8 times x squared is equal to the original problem, you got to put the x squared over here then, because it still has to equal 8x squared. So if you don't put any variable over here, you got to put that entire variable over here so that it'll still be equal, okay? It still has to multiply together to be equal to 8x squared. Okay, then we figure out what the first radical is equal to. It is equal to 2, and so that gives us this term right here. Same exact thing here, only difference is that you factor out the 27 instead of the 8. The x squared, nothing comes out of that for the same reason as in the other radical over here. And we end up with 3 times the cube root of x squared. We go back and we plug in those radical terms to replace the old radicals, but the outside parts are still there like we've been talking about. The 5 and the minus 2 are still there. So you got to multiply the 5 times the new outside part to get 10. You got to multiply the negative 2 times the new outside part 3 that's down here. Okay, multiply that, you get minus 6. And now you know what terms are in front of what single term. You know what single term is in front of each radical. The 10 and the minus 6 are those single terms that are in front of each radical. And so 10 minus 6 gives you 4, and the radical stays the same. It is the same radical, and then it stays as the same radical. Okay, so that is how you add and subtract radical terms. Okay, again, when you multiply and divide radical terms, the radicals don't need to be the same, so you don't need to try to make them the same. Okay, we'll talk about that in the next video. Okay, but I just wanted to clear that up now. Okay, it's always good to kind of put all that together. the difference between adding and subtracting versus multiplying and dividing. Okay, so but that does it for section 9.3. Okay, our next video will actually be 9.5. We're going to skip 9.4 in this class because a lot of the stuff in 9.4 is it's kind of a section that does a lot of review of what we've already learned in the first 3 sections of this chapter. So we're going to skip that, and we're going to move on to 9.5. So I'll see you back here for 9.5 in the next video, and you have a good day.